A capacitor. One capacitor is there in series with a coil of 8 ohms and inductance of 80 millihenry. So I am putting all these things. So you can put up as it is or you can put in your own convenient way. First you can draw the coil and capacitor or capacitor and coil. It's your wish. So this is a capacitor and there is a coil. Coil has a resistance and its inductance. So this entire thing is connected across 200 volts. How much is the frequency? 100 hertz. So next, that's all. So now let me put up the things here minus jxc. Whenever we see the AC circuit, we preferably choose the impedances instead of the resistances for inductor and capacitor. So this is jxl. Now can we calculate these two things? jxc and xl. How much is xc? xc is equal to 1 by omega c. So can somebody tell me this 2 pi f is 100, c is c, capacitance, 40 micro, 40 into 10 power minus 6. How much is this value? Anybody is listening my class or just anyone is there? Yeah. So my efforts are not going to be waste, right? You are listening, right? Yeah. So how much is XC? 39.788 ohms. Units also important. Ohms. XL. XL is equal to omega L. So omega is equal to 2 pi f into L. L is how much? 80 millihenry. 80 into 10 power minus 3. How much is this value? 2 pi f into 80 into 10 power minus 3. 50.26. Very good. 50.26 ohms. Now I'll put up those things over here directly. Let me choose different color. This has minus 39.788J. This has 50.26J. These are what the impedances. Now what is A? Question number A. Question number A is circuit impedance. A. What is the circuit impedance? Total circuit impedance. How much is that? So each of the elements are connected in series to each other. So we have to add up all the impedances. And let me put the resistance also. How much is resistance here? 8 ohm. So this is 8 ohm. 8 ohms. Now add up all these. So like minus 39.788 J plus 8 plus 50.26 J. Now put up this ZT in polar form. So you will get the magnitude of that minus 39.788 I plus 8 plus 50.26 I is equal to 13.178 at an angle of, somebody should spell, minus or plus? Madam, minus or plus? I got plus. Why? Is it? Just 1 second. I think I missed. No, 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 no. See, the inductive part is more. The capacitive part is less. So what is the resultant of that? It look like inductive. In inductive case, angle should be positive. Check your calculator, madam, once again. Type proper. Plus, right? Yeah. So the angle is plus. Why I am saying strongly this is plus is that, so inductive part is more. This is more than this one, capacitive part. So when like XL is greater than XC, what we got? Inductive nature. So inductive nature means angle should be positive. Capacitive nature means angle should be negative. For the impedance, I am talking about the impedance. Now, so just the magnitude here is equal to mod ZT is equal to 13.178 ohms. This is what the answer. Next thing is what they are asking. Circuit impedance is over. The current flowing. So the current flowing. So instead of only calculating current magnitude, hereafter I will follow some trick in this way. Whether they asked only magnitude or not, it doesn't matter for me. I will try to stay in the phasor forms. So let us say this is the current I bar, and let voltage as a reference. Why? Because current is not given, only voltage is given. Voltage Vs is equal to magnitude of the voltage is 200, angle I am considering as 0. That what we are considering. We are taking voltage as a reference. Reference in the sense that angle we are considering as a 0. This is reference. This is my assumption. With respect to this, I will calculate every other parameter. So here, now if Vs is this, so can I calculate the current phasor as voltage phasor divided by impedance? Total impedance, try to check it. So this is 200 at an angle 0 divided by, how much is the impedance? Impedance, don't put here only magnitude. Again, polar form, completely magnitude and angle. 13.178 at an angle of 52.62. How much is the current? How much is the current? Hmm. 200 divided by this entire thing. Is that correct? Everyone got same thing? 178. Shift at an angle of 52.62. So I am also doing the calculations. Yeah, 15.176. 15.176 at an angle of minus 52.62 degrees. Clear? So amperes. But in generally what we need is current. Which current is RMS value of the current. So magnitude of the current is equal to 15.176 amperes. Why I am putting the phasor is that later somebody may ask how much is the angle difference between voltage and current. That's why directly I can put up everything in phasor form as like this, so that I'll get the next answer also readily. See that, see phase angle between voltage and current. So they are saying phase angle between voltage and current means source voltage angle minus source current angle. How much is the voltage angle? 0. How much is the current angle? Minus of minus 52.62 degrees. So this is equal to 52.62 degrees. That is the angle between the voltage and current. Clear? Yeah. So obviously, see, you can even think of the phasor diagram again. See, current angle is at negative, voltage angle is at 0. What does it means is like this. If voltage is somewhere here, then your current is somewhere here, like downward. This is the current. Green color one is the current. So this is the current I bar, and this is your voltage, black color one, Vs. Now the angle between this is theta. How much is this theta is 52.62. Now you can check that the current is lagging the voltage. So you can write here as lagging. This lagging leading is always with respect to current. Is the current lagging the voltage or is the current leading the voltage? Okay. Right. So C is over D. Voltage across the coil. Voltage across the coil and voltage across the capacitor. This is little tricky. Voltage across the coil is nothing but voltage across the R and L. Why? Because they said initially that this thing. They said that this entire thing is the coil, which I am putting in the green color dotted lines. So this entire thing is the coil. Now voltage across the coil is nothing but this one. This entire thing let me consider as a V coil. So that what we need to find. So how we find it? It is simple as like this. Let me take up this diagram. Why? Because I want to explain with the diagram. So just, oh, sorry, move on downside. Okay, let me create new page. Yeah. So here I want the voltage across the coil, for which what I will do is that first I will give the general idea. Think about the coil voltage as like this. Can I write the coil voltage as like this? V coil phasor is equal to current through the coil is how much? I phasor into impedance of the coil. Let me call as Z coil, coil impedance. Now how much is the Z coil is? You can write Z coil is equal to only that part, that is 8 plus 50.26J. If you want, you can put up this in polar form. So give me the answer quickly. 8 plus 50.26I is 50.89 at an angle of 80.955. Is that clear? Yeah. Yeah. So now we already know something, that the current is already we calculated. How much is the current? This one. This one is the current. So current is including phasor. That's why. So there is some advantage, even if they don't ask phasor calculations, I will do that. Why? Because here I can directly use that current. Check it. So this is what the current into coil impedance. Coil impedance is this one. So you multiply these two, so you will get your answer. Answer in which form? Answer in phasor form, into. So how much is this answer? Coil voltage phasor. How much is the coil voltage phasor? Somebody multiply these two carefully. So 15.176 at an angle of minus 52.62 into I answer. I got 772.34 at an angle of 28.33. Is this correct? So this is volts. This is volts. Now, generally, what we need is only magnitude. So coil voltage magnitude is equal to 772.34 volts. So what else we need? So 772.1 they had given some approximation. Actually we were approximating these things. So see here, when we converted this into polar form, we approximated as 50.89. This also 80.955. If we would have taken these and this current amplitude also perfectly all the things, So we will get exactly that value. Okay, no issue. So what else is left? Voltage across the capacitor. Now again same thing, voltage across the capacitor also you can do in the similar way. How? VC phasor is equal to how much is the current through capacitor? I phasor. How much is the impedance of the capacitor? ZC. So now you will get the things. So I don't want to even calculate this. So you know how to do this, right? So this is 15.176 at an angle of minus 52.62, and the impedance is, how much is the impedance? Minus 39.788 J, or at an angle 90, or if minus is removed, at an angle minus 90. So in either of the form you can put up, you will get the answer. It doesn't matter. Somebody give me this answer. So minus 39.788 I. 603.822. All of you got same answer? Minus 142.62 degrees. But what we need is only magnitude. So VC mod is equal to 603.822 volts.